Welcome back, math students. Today we're going to talk about one more kind of transformation. It's called a dilation. And it's going to be different than the other ones that we've talked about because in a dilation, we're going to be changing the size of the shape. In all of our other transformations, the pre-image and the image were congruent. They were exactly the same size and shape. Now this is going to be the same shape, but it's going to change the size. So it's going to change the size, but it will not change the shape. The scale factor tells us how much we're changing the size, and if it's getting bigger or getting smaller. We call that an enlargement or a reduction, and if it's going to be enlarged or reduced. And that's going to be always comparing a side length or an ordered pair or something from the new and the original shapes. So an enlargement has a scale factor that's more than 1. So if it had a scale factor of 2, for instance, it would be getting bigger because it's going to be doubling everything in size. If it's a reduction, it's going to have a fraction that's less than 1. So sometimes somewhere between 0 and 1, like a half or 2/3 or something like that. I'm not going to try to trick you here and give you a scale factor typically of something like 5/2, because that's really 2.5. It looks like a fraction, but it's more than 1. So we're looking at fractions that are just between 0 and 1. So it's going to get smaller with that. And then again, instead of having congruent shapes, we will be getting similar figures. So same shape, but different sizes. For the dilations then, we've got these two puzzle pieces. If I'm going from this big piece, this one, down to the little piece, that's called a reduction. If I would go the other way around, if I said that this was my original piece and I go to that one's going to be an enlargement. But either way, you can see that these are similar. They're the same shape, but they're different sizes. They're not turning, they're not flipping, they're not sliding. It's just changing the size. So on here, it says every dilation has a fixed point that is the center of the dilation. The center of the dilation every single time is going to be the origin. Same thing that we did with the rotations, okay? So when we are changing the size of that, the origin is going to matter a little bit in terms of how we can check this. So when we have an original shape, an original figure right here like ABC, and we're going to go up to A prime, B prime, C prime. Usually we use capital letters, but it's going to this shape right here. These are similar, they're the same shape, but they are different sizes. The new shape is bigger, so that's called an enlargement. We're going to multiply every ordered pair by some constant. They use the letter K for this, for the scale factor. I'm not sure why they picked K, but that's just what they're going to do. They're going to multiply the X and the Y all by that same number. And then here's the way that you can check these. The center of the dilation being at the origin means that I could draw a line from the origin through point A and A prime. Not a very straight line, but it should go right through both of them if we dilated everything correctly. This one isn't drawn, but I should be able to go through B and B prime. Ooh, not very good with the line there, but they all line up, even if I didn't have a very good line there for you. This has a scale factor of 2, which means that this segment, for instance, is only 1 unit long. In the new image, it's 2 units long. Or let's go with point C. Point C is at the ordered pair 2, 1. C prime is at 4, 2. Each of the numbers got multiplied by 2 because the scale factor was 2. The top part of this is what you're going to find on your pink sheet. For a scale factor, this time it's saying A. Some books say A, some books say K. I want you to be okay with either one of them. But it also just means that whatever the scale factor is, that's what I'm going to multiply the X and the Y by. okay? This is the same picture that we just saw, but if I don't know the scale factor, on the last slide I told you the scale factors too, I can find it from this. So the length of the image, remember that's the new one, over the length of the original. So before I looked at the horizontal pieces, so let's look at the vertical pieces. Here, this is 1, this is 2, because it goes from 2 to 4. I know there's a whole bunch of little squares there. But the length of the new image was 4. The length of, was 2. And the original one was 1. So that gives me a scale factor of 2. Okay. You could do that with any just like we did it with point C, I could do the same thing with any of the ordered pairs even. I could take, for instance, point B, which is at 1, 1, and point B prime, which is at 2, 2. It doesn't have to be a length. It can be just the X values or just the Y values. So if I would take the X values of the new image and the X value of the original image, that's going to be 2 for the new one, 1 for the original one. Scale factor of 2. It's always new over the original. Okay. In this problem, we've got this quadrilateral that's already graphed, JKMN, and I want to dilate it with a scale factor of 1/2. Because it's less than 1, that means that this is going to be a reduction. It's going to reduce, it's going to get smaller. Everything's going to get multiplied by 1/2. So if I would take all of these ordered pairs, now I've got all the work shown right here, but if I would just cut each number in half, half of 2, I'm looking at point J right now, half of 2 is 1, half of 4 is 2, so my ordered pair is going to be 1, 2. Don't forget the parentheses, don't forget the comma. For point K, 2, 6 gets cut in half, and that would be 1, 3 for K prime. For M, I had 8, 6, cut them both in half. For M prime, I'm going to have 4, 3. And for N, it would be 8, 2 turns into 4, 1. When I graph that, when I graph those points, so I would have that J is at 1, 2, J prime that is. K prime is at 1, 3. M prime is at 4, 3. And N prime is at 4, 1. So here's my new image. You can see it's the same shape, and you could draw a line from the vertex or from the origin through each pair of vertices that match up. So those are my J's, here are my K's, and then my M's and my N's. They all line up. Again, there's a graph that's better than mine, but that works. Now I have a scale factor of 2. It's more than 1, it means it's going to be an enlargement. Every number in the ordered pairs are going to get doubled. So for point A at 1, -2, when I double it, that'll be at 2, -4 for A prime. B, when I double 0, I'm still going to 0. But 2 times 2 is going to be 4 for B prime. And then C prime is going to be at -4, -2. So when I graph that, A prime is at 2, -4. I'll move this just a little bit. 2, -4. B prime is at 0, 4. C prime is at -4, -2. So here is my new shape, my new image. And then again, when I go from the origin, this one's pretty easy, right on the axis. Here are my C's lined up, and here are my A's lined up. Drawing those extra lines isn't necessary, but it is a quick way to check to make sure that you dilated everything correctly, because that way you'll know that it lined up. For this example, and I hope that you've been following along and doing these in your notes, I have this original eagle head right here. And they want to enlarge that so that it can be painted on the gym doors. I want to know what the scale factor is. Now, you have a couple of options here. They have this with showing some work and doing some subtractions. They said for the X values, for the new image, 9 minus 3 would give me 6 for that length, or you could just count that it's 6 squares. And then for the original, the X values, 3 minus 1 would give you 2. And 6 over 2 is just going to give me a scale factor of 3. Because it's more than 1, obviously, it's an enlargement. You could also have just looked at things like this ordered pair to this ordered pair. Multiply the X and the Y by 3, and you get the new point. For number 8, we've got our vertices graphed. I want a scale factor of 1/3. In your head, I'm hoping that you're figuring out what kind of dilation this is. It is going to be getting smaller, so it's called a reduction. Scale factor of 1/3 really is going to divide everything by 3. So R prime, instead of -3, it'll be -1. Instead of 6, it'll be 2. We're dividing by 3. S prime, divide by 3, I would get 1 and 4. For T prime, I'm going to get 1 and 1. So when I graph that, -3, -6. Oh, I'm sorry, -3. Nope, that was the original point. -1, 2, right here. That's R prime. S prime is at 1, 4. Yep, that's okay. I thought I messed up. T prime is at 1, 1. A scale factor of 1/3 really does make it a lot smaller. So that's my new image. And then when I connect the origin through the R's, it matches up. Through the S's, it matches up. And through the T's, it matches up. Last 2 questions. So we've got a figure that has those vertices that are given to you for X, Y, and Z. And I want to have a scale factor of 3, which means everything gets multiplied by 3. So clearly, this first one isn't right because -3 times 3 is not going to be 0. That one doesn't work. -3 times 3 is also not -6, so that one doesn't work. If I look at H, -3 times 3, not that one. Here, multiply by 3, every single number gets multiplied by 3. J is the one that works. And for the last problem, finding a scale factor. So she wants an 8 by 10 inch photo reduced to a 2 by 2.5 inch. I don't need to use both dimensions. I only need to use one of them. So let's use the one that has the nicer numbers. I'm going to use the 8 and the 2. They're the corresponding sides. And remember, I need the new number over the original number. So it should be 2 over 8, which we can simplify to 1/4. Since we were reducing the picture, we were making it smaller, it should be less than 1, so that makes sense. Your worksheet today has several questions about just recognizing if shapes are dilations, and then actually performing some dilations, getting your original points graphed, using different scale factors to find the new ordered pairs and graphing those, and then deciding if it's an enlargement or a reduction. If you have any questions about this, let me know.